Hello ladies and gentlemen, and welcome back to our online distance learning for Algebra 1 here with Mr. Hagedorn. Today we are going to talk about 8.5 graphing quadratics in standard form. The first set of notes that I have here for you really are just our vocabulary words that we're going to be using. Remember, standard form is ax squared plus bx plus c. The graph that we're going to talk about is a U-shaped graph called a parabola. And the most basic of the quadratic functions that we're going to graph is the parent function, which is y equals x squared. The lowest or highest point of the parabola is known as the vertex. It'll also be the starting point for our graph. And then the line that passes through the vertex and divides it into two symmetric parts is known as the axis of symmetry. So with that in mind, let's take a look at the parent graph and how we would go through this. Like with any other graph, what we need to do is we need to figure out where we're going to start with this. And every time we do that, we want to start at the vertex. So in this case, the vertex actually ends up being the origin. And the reason that is because if we put 0 in for our x, 0 squared is 0, and there's our y. Now with our U-shaped picture here, what we're going to have is we're going to have two equal sides to the parabola. So if we take a look at this, going left and the right of our vertex, which if we graph it is right here at the origin 0, 0. If we go to the left to -1 and to the right positive 1, the outcomes are always going to be the same because they are a mirror image of one another. -1 squared is 1 and 1 squared is 1. So there's the mirror image, -1, 1 and positive 1, 1. And if we continue that pattern, -2, +2, both -2 and +2 squared is 4. So we have -2, 4 and +2, 4. And then just one more for good measure, -3 and +3. If we square both of those inputs, we end up with an output of 9. So it would be -3, 9 and +3, 9. And that, ladies and gentlemen, is where we get our U-shaped graph known as a parabola. In this case, our vertex was the point 0, 0, and our axis of symmetry, what would cut this right in half, is the x of our vertex, which in this case is x equals 0. So now every other graph we're going to take a look at is actually going to come off of that parent graph and be in that same symmetrical pattern. So, do we change our graph at all in this case? Let's take a look first of all at the graph y equals 3x squared. So by adding a out front, what does that do to us? In this case, if we start at 0 again for our x, for our input, we still get an output of 0 because 0 squared is 0 times 3 is 0. So there's our origin as our vertex, which again also makes our axis of symmetry 0. So now if we go to the left and to the right like we did before, let's see if it affects the symmetry at all. So if we put a -1 and +1, 1 squared is 1 times 3 is 3, and -1 squared is 1 times 3 is also 3. So now we have the point 1, 3, and -1, 3. So if we take a look at what that did, really what it did to our graph compared to our parent graph is it's going to make it much steeper than its predecessor. And if we put a -2 on both sides, -2 squared is 4, +2 squared is 4, and 4 times 3 is 12. So now our outputs would be 12 and 12. So that would be 2, 12, and -2, 12. So again, as you can see, that's far steeper than the parent graph as it comes down, 2, through, back up, and we go from there. So in this case, you take a look, you can see if a is greater than 1, our graph becomes much steeper than its parent graph. But now let's take a look over here at the next one. It's y equals -1/4 x squared. Now in this case, we're using a fraction for a and it's negative. So let's see what happens here. So once again, let's start with x equals 0. Let's start with our input like we have for the other ones. 0 squared is still 0, and anything times 0 is 0. So once again, we start right here at the origin, and once again, our axis of symmetry is still 0. So now if we plug in -1 and positive 1. So again, negative 1 and positive 1 squared is 1, and 1 times negative 1/4 is negative 1/4. So here we're actually going to see a graph that goes out. It's not as narrow, it's not as steep, it's actually a more gradual or a wider graph than we've seen with the parent and with the y equals 3x squared. So in this case, it would be negative 1, negative 1/4, and positive 1, negative 1/4. And in this case, because a is negative, our parabola is also going to be opening downward. So a negative a gives us a downward opening parabola. So if we would plug in positive 2 and negative 2, well, 2 squared is 4 and negative 2 squared is 4. And 4 times negative 1/4 would be negative 1. So again, we see that mirror image. We see that axis of symmetry giving us the same points on both sides of the parabola. So negative 2, negative 1, and positive 2, negative 1. And this would give us a graph that would look something like this. Again, it's a more gradual decline in this case, and it is a decline because it's also a negative for our a. All right, so that's what a does. Let's take a look at the next one and see what adding c, or adding a constant, to this does. So once again, like we've done in other ones, let's start with 0 for our input. So in this case, if we put in 0, 0 squared is still 0, but in this case now we're adding 3. So the axis of symmetry here is still going to be found at 0. However, our vertex is not at the origin. Our vertex now moves up 3 spaces to the point 0, 3. So in this case, adding that c is going to move our vertex up and down from the origin. But once again, our axis of symmetry is still right down the middle. So if we go to the left and to the right, it should still give us that symmetric look. It should be the same output on both sides. So if we do that, again, 1 and negative 1 squared is 1, and 1 plus 3 is 4. So we still see the symmetry. We still see that change being the same, nothing different than what we had before. And then if we plug in 2 and negative 2 and 2 squared is 4, and 4 plus 3 is 7. So the symmetry is still there. Everything is still falling. We still have our U-shaped graph. It just happens to be that in this case, our U-shaped graph moved up from the origin. So if adding 3 moves it up 3, subtracting 2, I would guess, would mean we're going to be moving down 2. But let's go through it and take a look. So if we put in 0 for x, 0 squared is 0, minus 2 would be negative 2. And sure enough, what that does is it moves our vertex down 2 from the origin. The axis of symmetry is still right down the middle and is still at x equals 0. Now if we go to the left or to the right, the symmetric shape will still be there. The outputs will still be the same because that's the nature of how this is going to work in the quadratic formula. So if we take a look at that, we put it in 1 squared is 1, minus 2 is negative 1, and negative 1 squared is 1 minus 2 would also be negative 1. So again, we're still moving up, we're still symmetric, and again, if we plug in 2 and negative 2, that's 4, because 2 and negative 2 squared is 4, minus 2 is 2, so their outputs are also a symmetrical pattern. And once again, if we draw our graph down and through, touches there, comes back up, then there's our parabola with that. So now we've seen the effects that A has on it, and we've seen the effects that C has on it. So what would happen if we take a look at an example here where the effects of A and C are in the same graph together? Okay. So let's take a look at it again, starting in the exact same spot. Let's start in here with x equals 0 and see what happens. So if we start with x equals 0, 0 squared is 0, times negative 5 is 0, plus 2 is 2. So our vertex right here would be found at 0, 2, and the axis of symmetry, again, is the x of our vertex, which would be x equals 0. So here we see that C, being 2, moved it up, and the axis of symmetry remains exactly the same, cutting it down the middle. So now, again, going above and below that, we take a look at it from the standpoint of using our inputs of 1 and 2, and then -1 and -2 below that. So if we put in -1 squared is 1, times -5 is -5, plus 2 is -3, which we know will reflect and be the exact same thing at 1 because 1 and -1 squared are the exact same thing. So our points here would be -1, which would be right here, -3, and +1, -3. So here, because A is negative, once again, we are opening downward. And the next point then here would be putting in 2 and -2. Well, 2 and -2 squared is 4, times -5 is -20, plus 2 would be -18. So again, still opening downward here at -2 and +2 down at -18. We see that again, this is a much steeper graph because A is greater than 1 and it moves downward because A is negative. So in this case, if we would graph it, we'd get a graph that would look something like this. And compared to the parent graph, again, instead of the parent graph opening up, this one opens down because A is negative. And again, it's far steeper because A is greater than 1. So now we take a look at the items we have along with this that talk about the domain and range and then the x and y intercepts. Remember the domain, when we talked about it earlier in the year, was always the full set of x values, and the range is always the full set of the y values. Well, in this case, if we take a look at it from the standpoint of what can x not be, the answer is x cannot be nothing. And if you know anything about English, the double negative means, of course, that x can really be anything. So the domain for this would be x equals all real numbers, or ARM, like we talked about earlier this year. Now the range, we're asking ourselves here, what's the limit of our range? And now if you take a look at the graph, the vertex will always give you the limit of your range. In this case, our graph is opening downward, and it starts at, you got it, +2. How did I find that? In the vertex. Since A is negative, it's opening downward. The vertex becomes what's known as a maximum value for y. It's our maximum output. So with that, we take a look at our range being limited by 2 and everything below it. So our range in this case would be y is less than or equal to 2. Now again, the y-intercept, where does it cross the y-axis? In this case, the answer is it crosses the y-axis at 2. So the y-intercept in this case would be y equals 2, which also happens to be the vertex, but it's where it crosses the y-axis. And our x-intercepts in this case, which are just a little bit different, because with this one, it's not an exact value. Notice it crosses somewhere between when x is at the, or when the point is at the vertex of 0, 2, and then between that and then -1, -3, and 1, -3. So our x-intercepts, we would simply say, are between -1 and 0, or 0 and +1. Our x-intercepts, as you'll see a little bit later on, are also some of the answers or the solutions to our quadratic functions when graphing them on a coordinate plane. All right, ladies and gentlemen, that's part 1 of our lesson. So please stay tuned here, as we are very shortly going to be getting into part 2 of our lesson, which brings into play what happens if we now have the entire quadratic formula we need to graph, which is y equals ax squared plus bx plus c. All right, Lord's blessings on your day, you guys, and we'll talk to you soon.